Hi ladies, in this video we're going to go through scatterplots and their construction. So a scatterplot is used to show two numerical variables. Okay, so we don't use them for categorical, so just numerical data. So both variables have to be numerical. If they're not, you can't do a scatterplot. Okay, so a scatterplot is only for two numerical variables. So think about height and weight, time of day, and number of people driving to work, stuff like that. Okay, so has to be two sets of data, and they both have to have numbers basically, and they have to be numerical data because not all data with numbers is numerical. You got to remember that. Okay, so on your calculator, so even though the instructions are here, sometimes it's easier to see visually what to do. So if you need some help, you can watch this video. So add lists and spreadsheet. So we'll do the same example from the textbook, and we'll do another example, another question from the textbook as well. All right, when you're entering in the data, I always find it easier to do your explanatory variable and then your response variable. So keeping it in that order will hopefully minimize errors, because you can't go getting them mixed up because your statistics will be incorrect. So we'll look at what the question is, of the context of the question. So we're looking at the marks 10 students obtained on an examination and the time spent studying for the exam. So the time spent studying, so this person spent 4 hours studying and they got 41%. This person spent 36 hours studying. That's a lot of, maybe over the course of a period of time. Otherwise, that's a lot of time studying. And they got 87%. And when you think about the context of the problem, probably the more time you spend studying, the higher your result. Okay, so you might want to think about the context of the problem, a bit more in terms of that. Okay, so when we're filling in the rows, you can call them X and Y if you want to. You can call them EV and RV, so explanatory variable and the response variable. But the problem with doing stuff like that is unless you keep resetting your calculator or doing a new document each time, you're going to have a lot of variables in your calculator. So it's a good idea just to stick with what they're called. So for this one, they're called time. So you just type in time using the keypad down the bottom, and we've got mark. Now, when you're labeling your columns, it won't let you put in numbers or symbols. So you don't need to put in the percentages. If you had maybe like first day, second day, you would have to write the word first, not use the number 1, ST. Okay, it won't let you do that. So just remember, if the calculator comes up with an error, it could be because you're not naming your columns with just letters. Okay, you're using numbers as well. All right, so let's enter in the data. So it's extremely important that you don't rush this process, because if you get one number wrong, then everything's going to be wrong. And how annoying would that be, that just because you didn't enter in a number correctly, everything was wrong? So just taking your time, not missing anything. 61, 43, 65, 52. Now, they should be even, okay? So when you're looking at bivariate data, both columns should be equal. Okay, you have the same number of values in each column. And I would always go back and just double check my numbers, okay? Because as I said, that would probably take you about 30 seconds to do. And it's better to spend that 30 seconds checking than getting everything wrong. All right, so what we want to do is a scatter plot. So we go, we're going to add, so we're going to control add page. So control doc will add a page for us, add data and statistics, and you get something like this. So it looks like a scatter plot, but it's not a scatter plot for what we want. So down the bottom, so kind of think of this as your x-axis, we put our explanatory variable. So remember, your explanatory variable is your x variable. So x explanatory, x variable. So we put time down there, dots start to move, and then up here we want our mark, and there's our scatter plot. And you can kind of see as we're going across, its time is increasing, the mark is also increasing, and you can hover your little hand over to get what that value is. And I'll just make sure that we've covered everything. Okay, so you can see the final scatter plot there. All right, I'm going to just pause and I'll get a question from the textbook up. All right, so I'm going to go through a few of these questions first before we do construct a scatter plot. So for question 1, for which of the following pairs of variables would it be appropriate to construct a scatter plot? So remember, we're only looking at 2 numerical variables. So question A is clearly categorical. Okay, we're doing car color, blue, green, black, and its size is also categorical. So you wouldn't use a scatter plot for that. Food's taste is also categorical. Sweet, sour, bitter. Whoops. Wait. See if I can just turn my, I thought I did turn my emails off. A food's taste, sweet, sour, bitter, and its sugar content. So food's taste, categorical, sugar content is numerical, which is great. We do want numerical, but they both have to be numerical, so it can't be B. The weights in kilogram per centimetre of 12 oranges and their length in centimetres. So we have 2 numerical variables, so we can do a scatter plot for those. D, the time people spend exercising each day and their resting pulse rate. Okay, so that is also that would both be numerical. Okay, I just had to look at the answer because I knew it's a multiple choice question. We can't have 2 answers. So C, I didn't actually think too much about the question, but we're looking at the weights of oranges and the lengths of bananas, and obviously those 2 can't be related in any way, and they're both pretty much independent of each other, so we can't have C, so I apologize for that. But it's probably good to make that error because I wonder if people made that error as well. So even though they're both numerical, there's no relationship between the 2 because a weight of an orange does not influence the length of a banana. Okay, whereas D does make a bit more sense, the time people spend exercising each day and their resting pulse rate. So the more time you spend exercising, the better your heart rate or your resting pulse rate. Okay, so the answer for that one is D. All right, the scatter plot shown has been constructed from data collected to investigate the relationship between the amount of sleep a person has the night before a test and the number of mistakes they make on the test. Use a scatter plot to answer the following questions. Which is the EV and which is the RV? So remember, your explanatory variable goes on your x-axis, so the hours of sleep, and the RV on your y-axis. So if the scatter plot wasn't given to you, you would need to think about the context a bit more. So, you know, sometimes we make mistakes on a test and we stay up all night and thinking about them, but that's not the context of this problem. We're looking at, well, if we get more sleep, we're probably going to make less mistakes. If we don't get much sleep, we're probably prone to making more mistakes. So the number of mistakes you make depends on the hours of sleep. How many people in the data set, so you can just count up the dots, and how much sleep has the individual circled had and how many mistakes did they make. So we're just looking at the coordinates of this point. So it's 9, so 9 hours sleep and then 6 mistakes. All right, constructing scatter plots. So the table below shows the heights and weights of 8 people. So constructing a scatter plot there, let's have a look. So actually, before we move on, you've got to decide which one is the explanatory and which one is the response. It's not always written in that order. So some students falsely assume that it is X, Y, but it's not always explanatory response. So think about the context first and always write it on your sheet. So does height depend on weight, or does weight depend on height? So your weight does depend on height, so that's going to be your response. Can I write? Oh, I can't write on the textbook. Okay, so just maybe while we're here, height is your explanatory, weight is your response. Okay, so the taller we get, the heavier we are. So think about it. I'm quite tall. I'm about 178 centimeters. There it is. Oh, I'm a little bit heavier than 65 kilos, but you might be shorter than me, 163 kilos, and you obviously would weigh less than me. Oh, excuse me. All right, question 4. This one here. Now, age of wife, age of husband, it doesn't make it obvious. So let's read the question. Use your calculator to construct a scatter plot with a variable wife. And it says as the explanatory variable. So age of wife is your explanatory variable, age of husband is your response. Okay, so it tells you in the question. So if it's not immediately obvious, try reading the question and it might become obvious to you. What have we got? We got number of seats and airspeeds of 8 aircraft. So we've got airspeed and number of seats. So you'd probably think the more seats in a plane, and if they were all taken by passengers, the airspeed would be lower because the plane would be heavier. But it does tell us in the question which one. So the number as the explanatory. So this time your explanatory variable is on the bottom and the response variable is on the top. So when you're entering them into your calculator, put number first and then airspeed. All right, question 6. The table below shows the response time of 10 patients given a pain relief drug and the drug dosages. Which variable is the explanatory variable? So it's a bit hard to see the variables, but sometimes it's given you the measurement in brackets. So the drug dosage would be your independent or your explanatory variable, and the response time would be your response variable. And there's your values there. So explanatory variable, response variable. All right, so this question here, we've got the two variables, number in cinema and time. So think about the context. You've probably been to the cinemas before. If you get there really early, so maybe, so in this problem, the time is the time before the movie starts, or sorry, time after the ads started. So we've got when they start at 0, sorry, I've got 87 people in the cinema. So, you know, those people who are eager to watch the movie are there early. And then there might be some people who, you know, getting their popcorn, whatever, come in 15 minutes later after the ads have started, and, you know, it's increased to 123. And then 25 minutes after the ads started, you know, the movie's about to start and the cinema is filling up to 137. So the number in the cinema depends on time. So time is your explanatory variable in this case, and number in cinema is your response. All right, I'm going to stop there. I'm not going to do a scatter plot because I feel like explaining the which variable would probably help you, and you can just do that on your calculator. All right, bye.